let's look at this ion, CnO-, and the purpose of this video is to look at something called formal charge, which allows us to sort of more definitively decide which atom should be the central atom. From our clues, it seems like maybe the first one should be the central atom, but we don't really know. There's only one of each, so we don't really know, and carbon is the least electronegative. So let's go ahead and guess that carbon is in the middle, and we'll go ahead and draw our structure with our single bonds. So we've got 4 plus 5 plus 6 plus one more for the charge. So that's going to give us 16 electrons. When I go ahead and give everybody an octet, and I count, I realize I've got 20 electrons. So remember, 4 extra electrons means 2 double bonds or 1 triple bond. So the 3 resonance structures that I can draw for this are with a triple bond, or with 2 double bonds, or with the triple bond in a different place. And of course I give everybody their full octet. And since it's an ion, I go ahead and go like this. Now the interesting thing is that the average of all 3 of these is actually just the middle one. So quite frequently, the only thing that we'll do is go ahead and just draw that middle one. That if you just drew this, that would be okay. If you drew all 3, that would be okay also. So now that we've got our structure, what we're going to do is we're going to look at structures where we put carbon in the middle, and then a structure where we put nitrogen in the middle, and a structure where we put oxygen in the middle, and see which one's best. So these are the 3 structures that we might end up with. The first one with nitrogen in the middle, the second one with carbon in the middle, and the third one with oxygen in the middle. And we're going to calculate something called a formal charge. There's an official formal equation for a formal charge, but frankly it's a little annoying. So instead we're going to do it a shortcut way. So the first thing you need to remember is that carbon has 4 valence electrons, nitrogen has 5, and oxygen has 6. So what we're going to do is we're going to compare that to the number of electrons attached to it right now. So this carbon right here, if you look, it has 1, 2, 3, 4, and you count these once. It has 1, it's sharing, so if we count them once, I go 1, 2, 3, 4, 5, 6. 6 is 2 more electrons than the valence electrons 4, so its formal charge is -2. So it should have 4 electrons, and it has 6. 6 is 2 more negative, so -2. Nitrogen has 1, 2, 3, 4. Its valence electrons are 5. That's 1 less than it should have, so we say its formal charge is +1. Oxygen has 1, 2, 3, 4, 5, 6. It should have 6. We say its formal charge is 0. So hopefully this is making sense. If we go to the next one, again we go 1, 2, 3, 4, 5, 6. So 6 is 1 more than nitrogen's 5, so its formal charge is -1. Carbon has 1, 2, 3, 4. That's what it should have, so its formal charge is 0. Oxygen has 1, 2, 3, 4, 5, 6. Should have 6, so 0. You'll notice that the formal charges will add up to whatever the charge is on the ion, or 0 if it's a neutral compound. That's one way to check and see if you're doing it correctly. In this third one, carbon has 1, 2, 3, 4, 5, 6. So that's a -2. Nitrogen has 4. So that's a +2. And nitrogen has 2, 4, 6. So that is a -1. Again, this will add up to -1 just as a check. So, yippee, what does all of this mean? Well, the structure that is the best is the one that has the formal charges, as many formal charges equal to 0 as possible. So here, one of them equals 0, but the other 2 don't. Here, 2 of them equal 0, but 1 doesn't. Here, none of them equal 0. It would be impossible for all of them to equal 0, because the whole has to add up to -1. This is your best structure, this is the correct structure for that ion that we're talking about, and that's how you use formal charge. We'll practice that some more tomorrow.